Welcome to another edition of Binary Life, a channel that teaches new developers how to code by doing practical exercises so that you can see how the coding spirit is done and how the whole solution comes to life. Today we'll solve storage classes on Kubernetes. And before I deep dive into the exercises, storage classes is about configuring persistent storage dynamically on Kubernetes pods instead of precising allocated memory storage on the private claims PVs. You just identify maybe your storage class, as it's called, which is most of the times cloud storage spaces. Specify and configured and stored somewhere such that when a pod is created, they can just tap into that cloud space and we don't have to worry about allocating specific large storage blocks. This is how Kubernetes pods tap into cloud storage, be it AWS and Google Cloud or Azure. So let's get to some practical exercises. The concept needs to be read somewhere else before you can understand the exercise better, but if not, you can still look at it and then maybe from the practical walkthrough you can get an idea of how all of that works. So how many storage class do we have in this cluster right now? We can do that by checking the command get storage class in camel case or without camel case, or in a short format storage class SC. So we can see that there is just one. Alright, this looks like it's multiple lines just because of the size of the font. I can switch like this. It's just one line. Now, how about now? How many storage class exist? So they may have created some dynamically. We type the command and we have 3 storage class. I can also look at it this way. I say no headers because these capital letters here are the headers. I can do something like this, no headers. So see there are 3, and I can actually count. It's a short form. And there are actually 3 storage classes. Now, what is the name of the storage class that does not support dynamic volume provisioning? If I look at the 3 storage class, I can see this one has a volume, this one has a local path somewhere on rancher.io, and this one has no provisioner. So I guess it's this one. So it's local storage. Now, what is the volume binding mode used for this storage? So for this particular one, the volume binding mode is let me retype this simply like this with the headers. So for the local storage, the volume binding mode is wait for first consumer here. Now, what is the provisioner used for the storage class called podworks? This one. What is the provisioner? Can we look at it from here? This is the provisioner here. Podworks volume here. Setting things up. Is there a persistent volume claim? We can check that. kubectl get persistent volume claim. There is none. No. Right, let's fix that. Create a new persistent volume claim by name of local PVC and all of that. I'm going to create a file persistent volume claim.yaml, and I'm going to go to the Kubernetes documentation and look for persistent volume claim. Do I already have it? Persistent volume claim, so that we can get the syntax. I typed wrongly here, but we can see them here. It's about volumes. Let's look for persistent volume claims. This is a pod. This is a storage class. We might have to use that shortly. Persistent volumes and persistent volume claim somewhere. This is one. We can copy this one. Is there another one? It's a simple one here. Let's take this one. Okay. So I just copy paste, and the exercise says by name local PVC. So this PVC is supposed to be called local PVC. So PVC is persistent volume claim, which is like which analogy can I use? You know, you can have somebody can have money in the bank, and I'm going to give you a check to go and grab it. So the check is like your warrant that if the banker sees, he knows he's going to allocate the money for you. The same thing for PVCs. It's like your check to go and have access to a storage block somewhere. Okay, so this is the name of the PVC that should bind to the local volume local PV. It says we should request a volume of 500 megabytes, so I'm going to replace that 500 megabytes. 500 read write once. Okay, let's just, it's just by default, nothing precise concerning the access mode, so let's allow the one that is there by default. It should be bound to local PV. Now let me close this file. So remember, there were a series of storage classes that were created. So let me come back to the bank analogy. So first we have the bank, which is your PV, persistent volume, and then we have your check, like I said before, that can give you a warrant to go and grab your money in the bank, which are PVCs, persistent volume claim, like you're claiming a persistent volume, something like that. Now, where does storage class come in? Storage class is like the central bank. So if you create a storage class, it will create a persistent volume in the background. Like the central bank will always allocate money to the big banks, something like that. So there will always be a bank created in the background. That's the whole analogy behind all of this. So we were asked to create the claim, and we are saying that this claim should be bound to this bank, to this local PV. We never created a PV here. This we never created a PV. This is the list of storage classes here, and we are in the process of creating PVC. So between these two, there's supposed to be a PV. So if there is one, it means it must have been created by any of the storage classes. So let's check if there's any. Persistent volume, there is one here, and this PV is supposed to have been created by one of the storage classes. So let's just describe that PV so that we can have more information regarding that PV. This is the PV. Finalizers this. local volume. How about let's look at the whole definition file. So if I get that and I look at it in YAML format, right? So a PV, this PV was actually created like 6 minutes ago. It's created in the background. I wanted to see if you can look at the process that creates it, but we can't see it. So you just have to trust me on this one. When you create a storage class, it creates a PV on the background. So we were creating our PVC. Let's look at that. All right. So this is the name of our PVC requesting this block here. So there is a PV waiting for a PVC claim. So we don't need to mention the PV here. This claim is going to look at the existing PVs and reclaim 500 megabytes. So let's just apply the changes that was done on this PVC here, and let's check, and it seems to work, just that we used the wrong storage class. So what is special about it? What storage class is there? Oh yeah, we are supposed to mention the name of the storage class, which is a local storage, I think so. Let's see, let me quit this place. So let me check again the list of storage classes. So we're going to use this one, local storage. Okay, so like I said before, this is like a check to go to the bank, and the bank is the PV. So we're going to make this to be connected to the storage class. Normally it's supposed to be connected to the PV, but since the storage classes create PVs, we're going to make this attached to the storage class. This is why we have this failure here. So I'll look for how that is done. How does PVCs get attached to a storage class? This is it. We just mentioned the storage class name here. So I'm going to come here. Let's make this as easy as possible. I don't even need this block here. I'm going to replace this. Storage class. I'll put the name of the storage class, which was called local storage. Okay, so that PVC was created already, just with the correct storage class. So I'm going to have to delete that thing. And recreate. So let's recreate, and let's check, and it works. Let's go to the next question. What is the status of the newly created PVC? We just need to check that. kubectl get PVC is actually pending. Why is the PVC in a pending state despite making a valid claim? So we actually need to look at the description to have more information. Describe PVC. taking some time. Generally events are down here. We can check waiting for the first consumer to be created before binding. So consumer here should be a pod. There should be a pod that should be created to use all of this storage thing. Another way we can look at that is if we look at the list of storage classes, the binding mode is wait for first consumer, so we have to wait for a pod. So something like this, a pod consuming the volume is not scheduled. Now the storage class called local storage, this one makes use of the volume binding mode wait for consumer. So it's just explaining what we just did right now. Next question. Create a new pod called Nginx. Let's just go ahead, and this is how we create a pod. This is the name, and it says the image should be Nginx :Alpine. The pod should make use of the PVC, so we need additional configuration on top of that. So I'm going to put that in a file, dry run equals to client, which means don't actually run it, just make as if you're running. And let's put it in an output in a YAML format and redirect to a file. I'll call it my pod.yaml, and let's open that file and edit and add and make that pod and give that pod some volume, and that volume is going to come from our PVC that we just created. Like we'll hand him the check to go and collect the volume, something like that. So let's look at this pod definition files here that use PVCs and copy the syntax. So we're on the volume persistence, should be somewhere around here. This is a pod that uses normal volumes. Is a host part. It uses local volume, like a volume on the node on which it's running to get space, but we want it from the PVC. So let's look for another example that uses PVCs. We'll have to see that somewhere. This is the PVC. We need to look for a pod that uses a PVC. This is a pod that uses a persistent volume claim. So I'll copy this. This is a volume here. So I'll just call this my PVC volume, something like that. And here I need to put the name of the PVC, which was called local PVC. And what will happen when this pod will go with the check? This is the check, the PVC is a check to the bank to go and get the volume. The volume will be allocated and we need to mount it on the pod. That is why we're going to have to mount again the pod here. Volume mounts. Oops. We'll mount, not volume devices. Volume devices is a block. We'll do volume mounts. Let's look for volume mounts. Yeah, let's copy this. So we'll go to the pod definition and mount the volume. And which volume are we mounting? We're mounting this volume here inside the pod, and we can give it the path that we want. Oh, not the path that we want. Exercise say we should give this path. So it will be mounted under this folder inside the pod, and then we can save all of these and actually create the pod right now. kubectl, apply. I can also use create if I want. -f my pod, and let's check pod created with the correct image. It seems I used the wrong image. That's true because it's not Alpine here. So I need to remodify all of that and change the name of the image to Alpine. Let's save and let's look at the list of ports because we need to destroy that port and create another one. Actually, it couldn't even run because there was a problem of image. So I'm going to delete the port and call Nginx and recreate it with the right image. Let's recreate from the file and let's check. I think it's because it's not running, so let's just wait. Get port. Okay, it's running now since 8 seconds ago. Let's recheck and that's fine. Now what is the status of the local PVC? What is the status of, let's just look at all PVCs. Since the port is running, this PVC is bound to the port. We can actually confirm that. Let's describe the port that we just created right now in Nginx, and somewhere around the volumes you can see it has actually gotten some space right from the cloud, and it comes from where? It comes from this persistent volume claims here. All right, so what is the state? The state is bound here. And last question, create a storage class like this. The provisioner will be this one and this will be the binding mode. I just need to search for the syntax. Let's go to the storage documentation, storage class. So this everything about Kubernetes is easy. The commands are easier, but you need to understand the concepts behind every command you type, which is the most difficult part. So this is a sample storage class definition file. We're going to create one here. kubectl not storage class.yaml. So the name is supposed to be, according to the exercise, this. The provisioner is supposed to be this / no provider here. And then what is important, the volume binding mode. Wait for first consumer. This is the volume binding mode here. And I'm going to delete every other information that is not required for this exercise. 1, 2, 3, 4, 5, 6. I'll delete these 6 lines. And this is the simplest one we can have. Nothing more, nothing less. And then I'm going to apply or create everything that's inside that storage class definition. And let's check. We are fine. And next question, there is no next question because we are finished. So thanks for viewing, and don't forget to subscribe, and more practical Kubernetes labs will be coming up. And thanks for viewing, and see you on another video.